Hi everyone, this is Ben from Do Novo Nutrition again, and today I'm going to talk about bar velocity and using it for numerous applications. Really just the importance of how quickly you move the bar is on a lot of different lifting related parameters, and also it's something I recommend in my programs, so it's something I wanted to kind of clearly explain why I recommend people to do it, and just give you some ideas potentially with bar speed and how to use it in regulating your training. So again, I want to do a brief overview. This is something that's common in all of my videos. So before I get started, just kind of want to get into a little bit of the background of it. So right now we have multiple 1 rep max estimation methods. So there's like the Brzezicki formula and a bunch of other ones, and I'll kind of review a few of those, how they actually estimate 1 rep max and what the weakness of that is. And then I'll talk about a newer method based on bar speed, which is actually more accurate, more practical, and can be used for more purposes, and hopefully can be applied to everybody's training who's listening to this. And the last part isn't as applicable since I can't actually show you using a Tendo. This was actually one of my classroom presentations, so maybe I'll just kind of talk over that. So we have to start with a little bit of biomechanics here. Again, we can't ignore the science because that is really important to understanding all of this and why it works. So one thing that a Tendo unit does is you can actually measure average bar velocity, which is, again, like I said, very important. And you also can measure power. So as long as you give the right mass, again, you can get power based on this, measuring the velocity of the bar, how quickly you're moving it. So since power equals force times velocity, if we know power and velocity, we can solve for force. If we know total force, we could accurately predict 1 rep max, because if you actually think about it, your 1 rep max is the total force you're applying to the bar. The only problem is that if we look at purely just force output, then we could be talking about a static contraction, because you could put a ton of force on an object, but that doesn't necessarily mean you're actually moving that object. So think about pushing against the wall. You could put a ton of force on a wall, but unless you're actually going to break through that wall, you're not going to be able to, it's not going to be as applicable to a full range of motion, a combination contraction of eccentric and concentric. So we have to kind of explain or clearly establish that one a little better. So before I get a little bit further into what exactly I'm talking about here with 1 rep max estimation and bar speed and velocity, let's talk a little bit about the current prediction equations. So the good thing about all of these is that they're fairly accurate. So I believe the standard error is somewhere around 10%, which is okay. For basically, how quick it is. You just plug numbers into a calculator and you get like an immediate output of a 1 rep max estimation. So like I said, it can be performed quickly. It's really user friendly. You just have to know how many reps you did and what the weight on the bar was. So it's good for large groups if you're training a lot of people and you don't need any special equipment. As long as you have a gym and a barbell, you can and weights, you can actually estimate 1 rep max. The downside of this is when you use lighter loads, so things like 50%, 40%, typical like power training loads, you get a much less accurate reading. So basically one thing you'll see is when you look at the prediction equations, they say that it has to be 10 reps or less to fairly get an accurate estimation of 1 rep max. So what that means is you have to train close to or at muscular failure to get the best accuracy of these prediction equations. And this is the major thing, is they solely base that reading on the reps you perform at the given weight, not the force output. So I will explain a little more clearly what that exactly means and why it's so important. So how do we improve upon these flaws? And that force again is going to come, that lack of force is going to come into play here. So there's this study that was done in, it was published in the Journal of Strength and Conditioning Research, and it was done by Jidovtseff, and he actually did a few different studies on using accelerometers to measure or to predict 1 rep max, and he did a few other studies where he actually pulled this data from them to make this most impactful study that I'm talking about here. And so what he did was he actually measured his subjects 1 rep max first, so he had them go in and actually perform 1 rep max, and he measured their average velocity. So he actually didn't use a Tendo, but he used an accelerometer unit. It does the same thing, measures average velocity just like a Tendo, at 3 to 4 increasing loads that were between 30 and 95% of 1 rep max. So they covered a large span of these people's percent of 1 rep max. And what he did was he actually created, using this data, he created a linear regression to estimate the theoretical load at 0 velocity. So when I talked about in the beginning, if you apply an isometric contraction, you can get really high force. This is actually what he's getting, is he's finding where the intercept would be between the y-axis and the x-axis. So if you actually have the, let me think about this. If you have on the y-axis, if you have the velocity of the bar, and on the x-axis you have the load on the bar, if you use linear regression, you can actually find the y-intercept point, and that would tell you where at 0 velocity the amount of weight should be based on these previous data points. That might sound a little bit abstract. I do actually have a graph, and I am going to talk about how you can do this a little bit. But this is very important because it's measuring your force output, and it's taking velocity into account. So again, the thing about force is mass times acceleration. So there's 2 different ways you can have high force. If you move a high amount of mass, a large amount of mass slow, you can still have a high force. If you move a small amount of mass very fast, very quickly, you can have a high force as well. So this is why measuring force is really important, because we can get a really good assessment of how much pure force you're putting on the bar, and we can use that to measure your 1 rep max without you actually having to go up to failure. So this applies to, this isn't just for bodybuilders, for powerlifters. This can actually be for rehab and a lot of. So this is actually what the graph looks like that I was talking about. So like I said, we have on the y-axis we have the average velocity in meters per second, and on the x-axis we have this plots relative load percent 1 rep max, but on the actual charts that this would apply to that I use, it's going to be your actual weight on the bar you're using. And as you can see, at the y-intercept point you have LD0. LD0 again is the velocity or the weight you'd be using if bar velocity was 0. So hopefully this clears it up a little bit, because that might have been really confusing when I first explained it without any kind of visual. So what they actually found in this study was that there was a near perfect correlation, which is 0.98. Anybody who doesn't have any familiarity with statistics, that's extremely high. That's a correlation of 1 would be a perfect correlation. And this was between their actual 1 rep max and their predicted load at 0 velocity. So this is actually a lot more accurate than the weight estimation, the weight calculation formulas that estimate 1 rep max, like I was talking about before. And they found that average velocity of a typical successful 1 rep max attempt is 0.23 meters per second. Just to give you a reference for that, the Tendo unit suggests a 0.3 to 0.5 meters per second kind of range threshold for absolute strength, and they actually say that 0.3 you should terminate your sets at anything 0.3 or below because you're approaching muscular failure. So this does complement that, but actually some of my own data collection through training and using the Tendo, it does speak a little bit otherwise, but I think there's numerous reasons for that. I mean, I've actually successfully completed attempts that were below 0.23 meters per second, like even 0.15 meters per second. But I think training status has a lot to do with that. These individuals that were using this study, they weren't power lifters, or they weren't high frequency trained individuals, and one of the things we know about training is you have a lot of disinhibition of different neurological factors. Like one example is Golgi tendon organ disinhibition. What that means is actually you have these receptors on your tendon that measure how much force is put on them. And actually when you first start training, what you find is almost like your muscle just shuts off when you can't complete a rep, and that actually becomes disinhibited as you train more, and that's why you can kind of grind out reps better as you become more conditioned. And if anybody knows the way I train with a super high frequency and a really high volume, and I think that that partly explains the difference between my successful 1 rep max attempts and what they found in this study. Sorry for that digression, I just felt the need to explain that. Anyway though, what they developed from this study was this equation that you can use to predict 1 rep max, which it uses the LD0, and you actually plug it in and you can get your projected 1 rep max. And what they found was a 7% standard error, even with loads of greater than or equal to 35% 1 rep max. So what does that actually mean? That means that you could go in and do a power workout, and you could actually get a really accurate prediction of what your 1 rep max is based on those data points for that day without even going close to failure. So that's a huge thing. I mean, just some of the applications off the top of my head I can think about with this is if you're tapering for a powerlifting meet and you don't want to train super heavy, especially in your last week before a meet, and you want to see an idea of where your max is so you can plan your attempts, that's a huge thing. You can measure in real time every day where your 1 rep max is predicted, so you can kind of track your progression over time and compare those data points to see if you're having negative effects from training. Like obviously if your 1 rep max continues to decline over a time period, there's an issue. You probably are going to need to taper, and that's a really huge thing. So it's a really beneficial tool that you can have. And what does 7% standard error really mean? It's about 4 kilos. And this is something I can say in my experience using it, I guess somewhat anecdotal experience, it's been spot on. I mean, the furthest it's ever been off has been about 5 pounds of my actual 1 rep max versus what the equation comes out to be. So it is really close. And why is this really important for everybody? I did kind of address this a little bit. I did talk about how it applies to tapering for meets. One thing is, if you really like percentage-based training, you can actually use those numbers during your warm-up to determine your work sets. So if you do 3 or 4 warm-up sets and you estimate your 1 rep max, then you have your 1 rep max for that day. So that in its purest form is auto-regulation. So you can use 80% of that number as opposed to 80% of a number that you maxed out at 6 weeks ago. Again, you can avoid training to failure. You don't have to 1 rep max to find out a good idea of what your 1 rep max is, where it is. So better recovery, less nervous system overload, and again, you can tolerate more volume or frequency. That's the major thing. This could be a whole nother presentation, and I probably will get into this more so in my periodization presentation. But a big thing that can determine how well you can tolerate high training is one of them is how often you introduce this stimulus. So you will adapt if you train really heavy to failure all the time, but you still will run the risk much higher of injury and a lot of other problems that will kind of become inhibiting factors if you train super close to failure all the time. So if you can actually use this and not have to go that heavy all the time, it can possibly give you greater longevity and better effectiveness with your training. Again, like I said, it has a broader application to not just powerlifters, not just bodybuilders, for even people in gyms, in rehab settings. And the one drawback that I didn't mention that I think is going to be clear to everybody is it does require an accelerometer. There is an app for that. It's called Fitness G Meter. The only difference is that actually measures in G's. So you would actually have to do the math. G's are using gravity. So I think it has 1, 2, 3, and you'd have to multiply that by the constant for gravity to get your acceleration. So that might be a little more work, but I do think new solutions for cheaper accelerometers are being worked out. Honestly, I can tell you myself that the Tendo has been probably one of the best training related purchases I've ever made. So again, if you're super serious about this, if you're training athletes, if you're training powerlifters or anything like that, it is something to consider because it will make training more effective. So how do we practically apply this? Let's say you actually have an accelerometer, or you're going to use this Fitness G Meter to attempt to do this, or even you want to use, well, RPs wouldn't work as well, so let's forget that one. So what you want to do is you want to measure the average velocity of 4 to 6 of your warm-up sets, and just track them down, track the load on the bar and the average velocity. And the most important thing you want to do here, this is something I didn't mention before, is you want to move the bar as fast as you possibly can, because obviously if you warm up at a slow pace, like a slow rep pace, and you have 45 pounds, it's just an empty bar and you're moving it really slow, obviously your force is going to be impacted by that. Again, force is mass times acceleration, so you have to accelerate the bar as fast as you can, even on heavier sets. Again, what you're trying to get here is the maximum amount of force you can produce. So to do that, you have to move the bar fast. You want to try to cover a span of at least 0.5 meters per second, and you should be doing that if you use about an average of 5 warm-up sets. This I didn't show you. If anybody's actually really interested in doing this, you can email me and I could give you my spreadsheet, and you can use it to estimate warm-up max. I have this equation plugged into it. I can show you how to actually plot a linear regression in Excel or in SPSS if you have that. The thing about SPSS is you can actually get the exact intercept point and the number for that point. So it's going to be a little more accurate through SPSS, but Excel is still really close. And basically all you're going to do from that point, once you have LD0, is you're just going to plug it in to the equation and you can estimate your 1 rep max. So like I said, the application part, unfortunately I can't show you. If enough people are interested in this, I actually will record a video of me doing it, and I can show you, I can record a video of me actually plugging all this equation, the equations into Excel or SPSS, and I can show you the output and take you step by step through how you do it.